this question is about integration mainly, but the first part is about differentiation. Given that 2x equals tangent y, show that dy dx equals 2 over 1 plus 4x squared. So from tangent y equals 2x, we can use inverse tangent both sides, so we have y equals inverse tangent 2x. The dy dx is, if you look at the MF19 formula, the derivative of inverse tangent is 1 over 1 plus x squared. Since the angle we are doing, not the angle actually, the value we are dealing with is 2x, so we use 2x all squared. So this is multiplied by 2 because of the chain rule. So we have to multiply by the derivative of 2x, which is 2. Okay, chain rule. So we get what we need to prove. Now the second part, find the exact value of this integral. So first of all, we have this integration by parts formula, and actually you can just use, if you cancel out, you can just use this form, integral u dv equals uv minus integral v du. So to identify the u and the dv, because previously we know that the derivative of inverse tangent is this, so of course we're gonna have to differentiate inverse tangent, which means the u would be the inverse tangent and the dv would be x dx. So from u equals inverse tangent to x, we have the u prime or the du dx, which is this from the first part, which means if you multiply both sides by dx, we have du equals this. So we're gonna need this for the u and this for the du. And now the dv is x dx. So if the dv is x dx, we integrate both sides. So the integral of dv, or the integral of 1 dv, same thing. The integral of 1 dx is x, so the integral of 1 dv is v. The integral of x is 1/2 x squared, of course. So we're gonna need the v also and the dv. So we have everything we need. Let's substitute. So the u is inverse tangent to x, the v is 1/2 x squared, the v 1/2 x squared, the du is 2 over 1 plus x squared dx. So simplify a little here, 1/2 x squared inverse tangent to x minus, you can cancel out 1/2 times 2, so we have x squared over 1 plus 4x squared. Now we cannot integrate this directly actually, so this is an improper algebraic fraction, so you can just use polynomial long division. So using polynomial long division, x squared divided by 1 plus 4x squared, use this form so that it's systematic and simple. So the missing x is x term, the missing x term is 0x actually. So because we need to get x squared, we have to multiply 4x squared by 1/4. So 1/4 times 4x squared, we get x squared. 1/4 times 0x, we get 0x. 1/4 times 1, we get 1/4. And then we subtract. Remember, we have to cancel out. If we're doing it right, we have to cancel out. So we have only 0 minus 1/4, which is minus 1/4 is the remainder. This is the quotient. So we replace this improper fraction with the mixed algebraic fraction. This is the quotient plus remainder over the divisor. So after we do this long division, now we can integrate 1/4 easily. We get minus 1/4 x, and for this integration here, just minus times minus 1/4, that's plus 1/4. Now the integral of this guy here, we have to, we use the previous answer again here. So if the derivative of inverse tangent to x is 2 over 1 plus 4x squared, of course the integral of 2 over 1 plus 4x squared, the integral of this is inverse tangent 2x. So just modify to get exactly 2 over 1 plus 4x squared. We multiply by 2, but we divide by 2. So 1/4 times 1 is the same as 1/8 times 2. So now this form is exactly the same as what we have in the previous part here. So the integral is just inverse tangent 2x. Okay, so we have integrated everything. Now it's time to plug in the terminals. Root 3 over 2 and then 1 over 2 and then subtract. So because we have to use exact value here, we need to find exact value. So if you try using a calculator and you get decimals, that means you cannot use the exact value. So you have to do the calculations by chunking one small calculations at a time. So here you can do this part first using a calculator. You will get 3 over 8, and use this in the calculator. You will get pi over 3, and you do this in the calculator. You get root 3 over 8, and from this part in the calculator you get pi over 3, and from this part you're gonna get 1 over 8, and from here pi over 4, from here 1 over 8, and from here pi over 4. Now you can just factorize the pi, so factor out pi and pi, so you have 3 over 8 times 1/3 plus 1 over 8 times 1/3. You can factorize the pi here, and same thing here, you factor out the pi, factor out the pi, so you have this plus this. You can now use your calculator for this part and this part. From here you're gonna get 1 over 6 pi, and from here you're gonna get 1 over 16 pi, and you still have the rest, minus root 3 over 8 minus 1 over 8. So now you use your calculator again for the 1 over 6 minus 1 over 16, and you will get 5 over 48 pi, plus you still have 1 minus root 3 all over 8. So you can leave it in this form for the simplest exact value. Alright, I'll see you again.